All right, today we're going to go over the application of quadratics. So basically how you solve quadratic word problems. The first item that you need to complete before Thursday is the which does not belong. It follows the same structure as last time. So you pick which of these graphs you feel like doesn't belong, and then you explain to me why. There's not a wrong answer, so try to be creative with it. Don't always give me the most obvious choice, which is the bottom left. Try to get creative and tell me something different, like it has no solutions, or it has one solution, or something kind of creative, and use your vocabulary that I've provided for you. You can reply to that just on the lesson itself. So you can just type it into the comment box and then I'll grade them. All right, so on the quadratic graph, you have all of the vocabulary we talked about last week. The axis of symmetry is what cuts the graph in half evenly. You have the vertex, which is at the either maximum point or the...
Mommy, I need my seat.
Hold on, please, baby. Hold on. You have the vertex, which is at the, this week it's all a maximum value because we're talking about projectile motion, which is like balls flying through the air or rocket ships. You'll have the y-intercept, which is where the ball started. A lot of times it'll start at the origin, meaning it started on the ground. But think if you throw a ball, it doesn't start at the ground. So you will have a y-intercept value for those. You'll have a -0, which most of the time will not be applicable because it can't be in the real world scenario. You can't go back in time. And then you'll have the +0, which is usually where the ball or the object landed back on the ground. So let's move on to an example. All right, this is from your Google form for the week. So if a frog is sitting on the ground and then he jumps at an initial speed of 6 feet per second, here's the equation. H equals -6t squared plus 6t, where h is the frog's height at any given time. Okay, so they're asking how many seconds until the frog is back on the ground. So in order to find that, we're looking for that +0 value that I explained on the last slide. In order to find that, we need to find our zeros. The easiest way in this scenario to find your zeros is to use this equation and solve it for your intercepts. So if I were to solve it, I could solve it by GCF. Since I don't have a C value, I don't have a y-intercept, I can actually just GCF it out. If it's -6t squared plus 6t, what can factor out of that? A 6 and a t. So I'm going to take out a 6t from each part. So if I take out a 6t from -6t squared, I'm left with just -t. If I take out a 6t from a 6t, it just leaves me 1. So the factored form is 6t times -t plus 1. So if I solve that for my zeros, roots, or solutions, I would break it into two equations like we did a couple weeks ago. So we'd have 6t equals 0, and if I divide both sides by 6, it gives me t equals 0. That's my initial value. That's where it started at the origin. If I set the other one equal to 0, then I would subtract 1 from both sides and then divide by -1 to get t equals +1. So my 0 in this case, where the frog landed on the ground, is 1 second after he took off. So that's what you're going to type in as 1a, 1 second. All right, so for 1b, it says how many seconds after jumping will he be at his maximum height? So we're looking for his highest his highest value. We're looking for the x value of his highest, which, if you follow that line all the way down, is our axis of symmetry. So we're going to use our formula for the AOS. Negative b over 2a. And our b value is 6, so the opposite is 6 over 2 times our a value, which was negative 6. And that gives us negative 6 over negative 12, which is 1/2. So it says, how many seconds after jumping will he be at his maximum height? So a half a second after he jumps, you can actually type it in the Google form as 0.5 so that it's easier to type, because I know fractions are hard to type in the Google form. So in half a second, I guess you don't need the S, sorry, not a grammar teacher. Half a second after he takes off, he'll be at his highest height. Then it asks, how high does he jump? So what is his highest height? Well, the axis of symmetry gives us our X value of our vertex. Now they're asking, what is that Y value? Okay, so I'm actually gonna have to give myself some space over here. I'm gonna get this out of the way so I have a little more room. And I'm going to solve for the Y value of that vertex. So if I plug in the 0.5 as t, because that's the time, and I do it in both spots, now I'm going to solve. So 0.5 squared is equivalent to 0.25, and then 6 times a half is 3. So negative 6 times 0.25 is going to give me negative, sorry, I lost my train of thought, negative 1.5. And then I'm going to add 3 to that, which will give me positive 1.5. And these are feet, so I'm going to want to include my units. So his highest amount here at the vertex is 1.5 feet from the ground. So that will be the highest he jumps. That will be the C of your Google form. Now I'm going to show you, not necessarily a trick because it's not, I mean, it's completely allowed. I'm going to show you how to do this on a calculator. So here, if I type in the original equation using Desmos, change your X's, your H and your T to X's and Y's, because the graph only recognizes the X's and the Y's for the variables, so you want those to be X's and Y's. If you click here on the X axis, it'll give you your zeros. So you won't necessarily have to solve for them if you use the graph on the calculator. So here is our initial value. Here is where he landed back on the ground. If I click up here, it gives me my vertex value. Now you have to know how to read it. You have to know that this axis was time. So this is going to be the X values. You have to know that the Y axis was the height in feet. So you have to know that the 1.5 is height in feet. But if you can read the graph, that makes it so much easier and a lot less work. So that's the second option. So, all right, our next example is a dolphin jumping out of the water at an initial velocity of 16 feet per second. The equation is h equals negative 8t squared plus 16t. That's his height at any given time t. So question A asks, how long will the dolphin be in the air? So they're asking about the zeros. When does he land back in the water? So we're looking for the 0 value right here and the t value when we're there. So we're going to substitute h as 0 and solve for our x-intercepts. So if we have 0 equals negative 8t squared plus 16t, I can solve this by GCFing again, because I noticed the 8 and the 16 are both divisible by 8. So if I factor out an 8 and a t, because they both have an 8 and a t in them, then I'm left with negative t plus 2. So when I factor that out, both of them equal 0. 8t equals 0 will leave me with t equals 0, because 0 divided by 8 is still 0. The negative t plus 2 equal to 0 will leave me with negative t equals negative 2, so t equals positive 2. So our time of how long the dolphin will be in the air is 2 seconds. And please type the whole word in the Google form, otherwise I'll have to go back and credit you the points, so it won't have the right grade right off the bat. How high does the dolphin jump? That means they're asking for the y value of the vertex. So we first have to figure out where the vertex is. The easiest way to do that is to find our axis of symmetry first. So our axis of symmetry is the opposite of b over 2 times a. So our b value in this case was 16, so negative 16 over 2 times negative 8. That's going to give us negative 16 over negative 16, which is equivalent to positive 1. So this is not the answer to b. This is how long, this is the x value of our vertex, which is how long it took him to get to the highest point. But we can now use that value to find the height. So this is going to actually be the x value of the vertex, and we're going to plug it in as the x value of the equation to find that y value of the height. So it's not exactly as straightforward as it normally, or it was last question, because they changed up the order in how they asked the questions. But if I go ahead and solve this, I'll get negative 8 plus 16, which the height equals 8 feet. Okay, so B is going to be 8 feet, and we found that by finding our whole vertex. And then C we already answered. C was how long after leaving the water will he be at his highest point, which is the x value of the vertex, which was 1 second. Okay, real quick, I'm going to show you how to do that on a graph, because for some of you the graph is going to be an easier method. We're going to type in our equation, y equals negative 8x squared plus 16x. I apologize, my dog is beating on the back door. Now, in looking at this, here are my zeros. This is where he took off. This is where he landed. So that's our 2 seconds. That was letter A. If we look at our vertex, this gives us B and C. You just have to make sure you're answering the correct question. So the x value is time, and the y value is height. So in this case, B was asking about the height, which is the 8 feet, and C was asking about the time, and that was the 1 second. You are welcome to use Desmos to help you with all of the task cards. Please reach out if you have any questions. I'll do some more examples on Wednesday. Real quick, last slide. The things you need to get done this week are the which does not belong discussion question that we talked about at the beginning of this, and the Google Forms that I just did 2 examples with you. It's optional for you to go back and complete any late activities by Thursday so that you can get your grade up if you would like it to be higher. My grades have to be done by Friday. So those of you that have been submitting late work, I haven't taken off any points, but if you submit it after Friday this week, I can't accept it because my grades will already be closed. So please, please, please get it to me by Thursday. The last part is if you want to be a part of our talent show, you need to join this Google Classroom so that you can get the updates and all of the information about how to be a part of our talent show. It will be virtual, but it will be awesome, and it's always one of my favorite days. So if you have a talent, please think about doing it. I'd really like to see you guys. Alrighty, take care. P.S. My birthday is Wednesday if you want to just jump on to wish me a happy birthday. I miss you guys.